Let's talk about systems of linear equations. A system of linear equations is when you're given two or more linear equations and your goal is to find where do these equations intersect. So for example, let's say we had the equations y equals 3x plus 4 and y equals 5x minus 1. And I wanted to know where do these equations intersect. Well, one way that you can solve this, and the easiest way usually, is just by graphing. So we can go to Desmos and we have y equals 3x plus 4 and 5x minus 1. So 3x plus 4 and 5x minus 1. And when we graph these two equations, deleted the first one by accident. 3x plus 4 and 5x minus 1. When we graph these two equations, we can see that they intersect at this point, 2.5 comma 11.5. So that point right there is called the solution because that's where they intersect, right? Now let's say that instead of this system, let's say I had a different system of equations. What about 2x plus 3 and 2x minus 1? So these two equations, as you can see, they're parallel to each other, and it looks like they're just gonna go on forever being parallel, and they're never going to intersect, right? So when a pair of equations never intersects, and they're parallel, then that system has no solution. There's also one more case, which is, let's say we have y equals 2x plus 1, and let's say 3y equals 6x plus 3. You can see that what happens when I type in this blue equation is that the red equation, or the red line, disappears, right? It's not actually disappearing, it's just that the blue line is overlapping with the red line. You can see that if I toggle the blue line, it's overlapping with the red line. And that's because this blue equation, the second equation, is actually just a multiple of the first equation. If you take the first equation and multiply both sides by 3, you'll see that you get the second equation. So because these two equations are technically the same, they're just like multiples of each other, they overlap, right? When you graph them, they overlap, and thus they have infinite solutions. That's one more case. And of course, we already talked about when a system has exactly one solution, right? So those are sort of the different cases that we can have. Our system could have one solution, which is like this, could have no solutions, which is when they're parallel, like that, or it could have infinitely many solutions. That's generally the case with systems of equations. So now let's talk about how to solve them. Well, the easiest way to solve them, if you're just given a system of equations, is to graph them in Desmos and see where they intersect, or if they don't intersect. But sometimes you may need to use algebra, and sometimes it's not possible to use Desmos. So let's see how we can solve systems using algebra. The first method is called solving by substitution, and your goal is to reduce two equations with two variables into one equation with one variable. So for example, let's say we have this system. What we can do is, notice that we're given that x is equal to 2y and also that x plus y equals 3. Well, if we know that x is equal to 2y, we can actually just substitute or plug in this 2y into this value of x, because again, we know that this x is equal to 2y. So I'm just going to replace that x with 2y, and I end up getting 2y plus y equals 3. And notice how in this first equation, x plus y equals 3, you can't really solve for x or y, right? Because when you have two variables, for example, if I wanted to solve this equation I've just circled, let's say I wanted to solve it for y, right? I would get y equals negative x plus 3. That's not really a solution at all, right? Because I don't know like the actual value of y. I just know that it's equal to negative x plus 3, but I don't know what x is equal to, right? So I can't solve an equation if it has two variables. I can solve an equation if it only has one variable. When we've reduced this equation into 2y plus y equals 3, we can simplify it as 3y equals 3, and now I can divide both sides by 3, and I get that y is equal to 1. So once you reduce an equation into just one variable, you're actually able to solve it. So now that I know y is equal to 1, I can go back to this first equation, x is equal to 2y, and I can say, all right, well, x must equal to 2 times 1, right? Because y is equal to 1, so x equals 2. And so my solution is 2, 1, or x equals 2, y equals 1. And I could also solve this one using Desmos. I would just plug in x is equal to 2y. That's our first line. And also x plus y equals 3. And we can see that they intersect at this point. Oops, not that point, this one. 2, 1, which is what we found algebraically, right? So again, you can solve them using Desmos if it's like a simple problem, or if there's no trick to it, then you can generally solve a system of linear equations using Desmos, but sometimes you will need to use algebra. Alright, let's look at this one. We have y is equal to 5 minus 2x, and actually this one is better. Y is equal to 3x plus 2, and also y is equal to 7x minus 6. So we can see that y is equal to 3x plus 2, and y is also equal to 7x minus 6. So if y is equal to both of these things, then these two things should be equal to each other, right? Because we know that y is equal to y. Well, we know that y is equal to 3x plus 2, so I'm going to replace this y with 3x plus 2. We also know that y is equal to 7x minus 6, so I can replace this y with 7x minus 6. And now that I've done that, I've reduced these equations with two variables into one equation with one variable that I can solve for x, right? So I'll start off by subtracting both sides by 3x. And I get 2 is equal to 4x minus 6. Now I'll add 6 to both sides. And I get 4x equals 8. Divide both sides by 4. And I get x equals 2. Okay, now I can just go back to either one of these equations and plug in x equals 2 and use that to solve for y. So I get y is equal to 3 times 2 plus 2, which is 6 plus 2, or 8. So that's going to be my solution. And once again, I could plug this into Desmos. I get, let's see, y equals 3x plus 2, and y equals 7x minus 6, and we can see that they intersect at 2, 8, which is what we got here, right? 8 for y and 2 for x, so that checks out. Okay, there's one more way that you can solve a system of linear equations algebraically, and that's called solving by elimination. And the way that this works is you can actually treat equations as just like how you add and subtract numbers, you can also add and subtract equations, right? So let's look at what that means. Let's say that you have this system of equations. What we can do here is we can actually just add these two equations together. And what we would do is we would add the right side and we would add the left side. So on the right, 8 plus negative 1 is 7. So that's my new right-hand side of my equation. And then on the left, we can see 2x plus 5x is equal to 7x, and 3y minus 3y is actually equal to 0, right? They cancel out. So notice how we sort of eliminated the y because they canceled out, right? So we end up with 7x equals 7, and divide both sides by 7, x is equal to 1, right? Now I can go back to either one of my equations and plug in x and solve for y, right? So if I go to this one and I plug in x equals 1, I get 2 times 1, 3y equals 8, 2 plus 3y equals 8, 3y equals 6, and y is equal to 2. And again, we could solve this using Desmos as well, but it's good to know how to solve them algebraically. Okay, let's look at this one. In this case, it's not as simple as before, because notice how if we add these equations, 2x plus x equals 3x, 5y minus 2y is equal to 3y, 19 minus 4 is equal to 15. So unfortunately, we weren't able to eliminate any variables just by adding the equation. So we need to manipulate the equations first and then add them. So what I'm going to do is I'm going to take this second equation, x minus 2y is equal to negative 4, right? X minus 2y equals negative 4. And I'm going to multiply both sides of this equation by 2. So I get, let's see, on the left side, I get 2x minus 4y. And on the right side, I get negative 8. So 2x minus 4y equals negative 8. And again, this equation is equivalent to the first one. Because we just multiplied both sides by the same number, they're still equivalent equations. Okay, so what we can do now is I'll replace the second equation with 2x minus 4y equals negative 8. And notice that what happens is now the x's have a common coefficient, right? They have the same coefficient, which means that if I were to subtract, I'm not going to add them, right? Because if I added them, it would be like 4x plus y equals 11, right? So that doesn't really get us anywhere. Instead, what I'm going to do is I'm going to subtract them. So I get 2x minus 2x is 0, so I've eliminated x. 5y minus negative 4y. Remember that this is minus negative 4y, right? So 5y minus negative 4y. That's going to be 9y, right? Because when you have that double negative, it becomes positive. So this is going to be plus 9y. And then again, 19 minus negative 8. 19 minus negative 8 becomes 27. Again, that double negative becomes a positive. So 9y is equal to 27, and then divide both sides by 9, y is equal to 3. So notice how what I did was I couldn't eliminate any of the variables right off the bat, but what I noticed was that what I can do is I can multiply this equation by 2, and I can get that coefficient of 2 for the x so that they match here, and then I can just subtract the equations to eliminate the x variable. Now I have that y is equal to 3, and I can go back to either one of these equations, plug in y equals 3, and solve for x. So if I plug in y equals 3 over here, I get x minus 2 times just positive 3 is equal to negative 4. And if I take this equation, let me put it here, I'm going to do 2 times 3 is 6, so x minus 6 equals negative 4. Then add 6 to both sides, x is equal to 2. So I get x equals 2, y equals 3. And, once again, we can also solve this using Desmos or, check our answers. So we have 2x plus 5y equals 19. That's one of our equations. And the other one is x minus 2y equals negative 4. And we can see that we end up with 2, 3, which is exactly what we got over here, right? X equals 2, y is equal to 3. So we know that we did that correctly.